How are you doing, math learners? This is your free access math teacher Ash, and welcome to ML with Sir Ash. Today, we're going to solve these given quadratic equations using the factoring method. So, hit the subscribe button and notification bell for you to be updated of these cool math videos just like this. Hello math learners! Today, we're going to discuss another method of solving quadratic equations, and this is the factoring method. We already know how to solve quadratic equations using extracting square root. We all know that ax squared plus bx plus c is equal to 0 is the standard form for our quadratic equation. Sometimes, we have a given that we don't have any constant term. So that is the first scenario. On the second scenario, there are also times that we don't have any linear term, as what we had on the previous video about extracting square root. The third scenario is when ax squared plus bx plus c is complete, meaning the three terms is available, but the value of a is equal to 1. And the fourth scenario is that when your a is higher than 1 or greater than 1. So, let us start solving our given quadratic equations. We have here 3x squared plus 12x is equal to 0. This is an example of the first scenario in which we don't have a constant term. Now, how do we solve 3x squared plus 12x is equal to 0? So, in this kind of example, we're just going to apply what we have learned in factoring polynomials, specifically about common monomial factors. So what is the common monomial factor of 3x squared and 12x? Okay, so let's start first with 3 and 12. The common factor is 3. And then we go to x squared and x. The common factor is x. So the common monomial factor for these given two terms is 3x. Now, if we extract 3x from these given two terms, 3x squared divided by 3x, the answer is x. Okay? And then 12x divided by 3x, that is positive 4. So we have now our two factors, 3x and x plus 4. Now, if you are in this kind of scenario, what you will do is you just separate the two factors and equate it with 0. Okay, so that will become 3x equals 0 and x plus 4 equals 0. Now, remember that when solving x, we need to isolate our x. So, we just need to eliminate 3 here by dividing both sides of the equation by 3. This will be cancelled, and we have x, 0 divided by 3, that is 0. And this is the first value for our x. Now, going here, we just need to transpose our plus 4. So, this will become x is equal to 0 minus 4, and give us the result, x is equal to negative 4. And that is our final answer. So, for the values of x in this given example, we have x is equal to 0 and we have x is equal to negative 4. If you substitute 0 on the values of x, 0 squared is 0. 0 times 3 is 0. 12 times 0 is 0. So, 0 plus 0 is equal to 0. Check. Okay. Next, we go to negative 4. Negative 4 squared is equal to 16. 16 times 3 is 48. 12 times negative 4 is negative 48. So, positive 48 plus negative 48, that will give us 0. It's easy, right? Now, let's go to the next example. Now, for our next example, this is 15x squared minus 10x is equal to 0. This is still the same as our example in the first given. So, what we will do here is we will extract the common monomial factor. What is the factor of 15 and 10? That is 5. What is the factor of x squared and x? That is x. So we will extract 5x from these two given terms. So 15x squared divided by 5x, that is 3x. Alright. Negative 10x divided by 5x, that will give us negative 2 equals 0. So now, we have our two factors. Then, the next step is to separate them. That will equate them to 0. So 5x is equal to 0. And we have here 3x minus 2 is equal to 0. Now, let's solve first for the first factor. We divide both sides by 5 in order for 5 to be eliminated in the left side of the equation. So this will be cancelled out, giving us a value of 0. Because 0 divided by 5 is 0. Now going here, we need to transpose first our minus 2 or negative 2. So we have 3x is equal to 0 plus 2, giving us 3x is equal to 2. This is not yet finished, so we need to divide both sides by 3. This will be cancelled out, and the final answer is 2 divided by 3 cannot be, so we just have to copy our answer and we have 2 terms. So for the values of x, we have x is equal to 0 and we have x is equal to 2 terms. Now I will give you a simple trick about this kind of scenario. If you have a quadratic equation in which you don't have any constant term, remember this: one of the values is always equal to 0. Okay? And the other one is the other factor. Okay? Now, let us go to the next scenario. Okay, for our next example, we have x squared is equal to 49. This kind of example is where we don't have a linear term because this is our quadratic term and this is our constant term. Now, if you can remember our last video, we can apply extracting square root here. But since this is factoring, I will teach you how to apply factoring in this kind of scenario. First, you need to arrange your equation into standard form. So we have to transpose 49 into the left side of the equation. This will give us x squared minus 49 is equal to 0. Okay? Now, if you are in this level, what you will do is you just factor this equation. So x squared minus 49 is equal to 0. You have to factor x squared minus 49. Now this kind of an example is what we call the difference of two squares. Remember that the difference of two squares is a special product. So the difference of two squares can be factored by making two quantities to 0. You factor the first, x and x. You factor the last, that is 7 and 7. Then since this is negative, you just put positive and negative here because positive times negative is negative 49. Okay, by doing so, we just separate our factors. Then we will equate our factors by 0. Okay, so we have here negative 7 is equal to 0. Transpose this one and this will give us 0 minus 7, which is the final result, negative 7. How about this one? Transposing, this will give us 0 plus 7, giving us the final answer, positive 7. So we have two values of our x, negative 7 and positive 7. Okay? Very easy, right? Let's consider our next example. Now for our fourth example, we have 2x squared minus 162 is equal to 0. Now this is not yet a difference of two squares because 162 is not a perfect square. However, this is a two-process solution. Okay, the first one is we need to apply first our common monomial factor. Our common monomial factor here is 2, right? Because 2 and 162 is both even numbers. So if we divide the whole equation by 2, we divide the whole equation by 2, and here 2. We can cancel this, giving us x squared. 162 divided by 2, that is 81. And 0 divided by 2 is still 0. Now, why did I do this? Technically, if you can still simplify your equation, it's better to simplify in order for you to have a very easy access in solving your quadratic equation. Now, as you can see here, x squared minus 81 is equal to 0 is already an example of our difference of two squares. So, we can apply our factors. Those are two quantities equal to 0. Then factor x squared, we have x and x. Factors of 81 are 9 and 9. Then since this is minus, we can use positive and negative. So therefore, we just separate the two factors, equating them to 0. And solving them separately by transposing, so 0 minus 9, giving us a final result of negative 9. Okay, here, x transposing negative 9, this will give us 0 plus 9, giving us the final result of 9. So therefore, the values for our x are negative 9 and positive 9. Very easy, right? Okay, let us continue. So now we are down to our fifth example. We have here x squared plus 5x is equal to negative 6. As you can see, the three terms are complete. The quadratic term, the linear term, and the constant term. So in order for us to apply factoring in this kind of scenario, what we will do is first, you just need to arrange your equation into its standard form. So we need to transpose our negative 6. So we have x squared plus 5x plus 6 is equal to 0. Okay? Now, what we will do here is we will factor our trinomial. If you could still remember our grade 8 lesson about factoring polynomials, by doing so, you can just make two quantities and then factor first the first term, x squared. We have x and x. Now, this is quite tricky in this second part. What you will do is you factor 6, positive 6, such that when you add the factors, it must result to positive 5. Now, let's go in this part. What are the factors of 6? Positive 6. So since this is positive, we will just consider positive pairs. So that is 1 and 6. We also have 2 and 3 and nothing more. Though, for some people, they will consider negative 1 and negative 6, negative 2 and negative 3. However, we are talking about a sum of positive, which is positive 5. So therefore, we will just consider positive pairs. Okay, so by adding the factors, 1 plus 6 is 7, 2 plus 3 is 5. Now 5 is just the same as our middle term. So what we will do here is we will follow our 2-3 pair. Okay, so we will just put positive 2 here and positive 3 here is equal to 0. And that will be our factors for our x squared plus 5x plus 6. Now, the same scenario, what we will do is separate our factors and equate them into 0. So, x plus 2 is equal to 0 and x plus 3 is equal to 0. Solving for the values of x by transposing, we have 0 minus 2, giving us a final result of negative 2. Okay. We also have here x is equal to 0 minus 3, giving us the final result of negative 3. And that is the final answer. So for the values of x, we have x is equal to negative 2 and x is equal to negative 3. Easy, right? Now let us go to the sixth example. Okay, now for our sixth example, we have x squared minus x minus 12 is equal to 0. This example is already in the standard form, so we can now just apply our factoring method. So by doing so, we just make two quantities is equal to 0. Factor first the first term, that is x and x. And then factor negative 12, such that if you add them, the answer should be negative 1. Because we all know that negative x has a coefficient of 1. Okay, so negative x, that means negative 1. Okay, let me just clear that out. Okay, now we have negative 12 here. What are the factors of negative 12? Remember, if your product is negative, it is a combination of positive and negative. Okay, so that is negative 1 and positive 12. That is positive 1 and negative 12. That is positive 2 and negative 6. That is negative 2 and positive 6. Okay, we also have 3 and negative 4. And negative 3 and positive 4. These are the 6 pairs of factors for our negative 12. Now what we need to do is to add the factors, and if we arrive to this middle term, then that factors will be used. Okay, negative 1 plus 12, that is positive 11. 1 plus negative 12, that is negative 11. 2 plus negative 6, that is negative 4. Negative 2 plus 6, that is positive 4. 3 plus negative 4 is negative 1. Negative 3 plus 4 is positive 1. Therefore, negative 1, so this is our pair. So we need to use positive 3 and negative 4. So we have positive 3 or plus 3 and minus 4. Easy, right? Now, going to our separation solution or separate solution, we have x plus 3 is equal to 0, x minus 4 is equal to 0. Then we transpose, we solve for x. The plus 3 will be transposed, this will become 0 minus 3. giving us a final answer of negative 3. First answer of x. Next, x is equal to, transpose negative 4 or minus 4, we have 0 plus 4, giving us a final answer of 4. So these are the two values of our x, negative 3 and positive 4. Easy, right? Now let us go to a more challenging example. Okay, second to the last example. This is the final scenario where your a is higher or greater than 1. We have 2r squared plus 15r is equal to negative 28. First step is to arrange the equation into standard form. So we have 2r squared plus 15r. We transpose negative 28. This will become plus 28 and we have equal to 0. Okay? How do we apply factoring in this level? Some books are telling you to use trial and error in this scenario. However, I will give you a method in which there is less mistake, and that is what we call grouping. Okay, later you will learn it, but still we will apply factoring on at the end. Okay, so first is you need to multiply the first term and the last term. Okay, 2r squared times 28, and that is 56r squared. Okay, positive 56r squared. So what you need to do is you factor 56r squared such that the factors when added together, they will result to 15r. Okay, what are the factors of 56? We have r and 56r. Okay, next we have 2r times 28r. We also have 4r and 14r. And we also have 7r times 8r. Okay. Now we are just considering positive pairs because our middle term is positive. Okay? So, we're just gonna add these factors. We have 57r. We have 30r. We have 18r. And finally, we have 15r. Now, that answers our middle term. Okay, so we will use 7r and 8r. So now, in this part, you already know the factors for our 56r squared. What you will do is, you will replace 15r by this 7r and 8r. So what will happen? That will become 2r squared plus 7r plus 8r plus 28 is equal to 0. As you can see, the quadratic term and the constant term are not replaced. We just replace 15r with 7r and 8r. Both plus because our 7r and 8r are positive. Now, what we will do here is we will group them. By doing so, grouping, okay? So, we need to factor out their common monomial factor. So, 2 and 7, they don't have any GCF aside 1, okay? R squared and r, we have r. Okay, so that will be r. If we extract r from this group, it will have 2r plus 7. Okay. Next, we have 8r plus 28. What is the common factor for 8r and 28? So, since we don't have any r's for both terms, we just factor 8 and 28. So, what is the common factor of 8 and 28? We have 4. Okay, so that is 4. So, by doing so, if we extract 4 from 8r, we have 2r. If we extract 4 from 28, we have positive 7. Okay, now, as you can see, we have factors that are identical. So, what we will do is we consider them as 1. Okay, sorry for the plus sign. Okay, we will consider them as 1. So, 2r plus 7 equals 0. Now, this r and this plus 4 here, you will put them together. So, that is 3 plus 4. And that is the factors for this given equation. Okay? So 2r squared plus 15r plus 28, the two factors are r plus 4 and 2r plus 7. Question, did we answer our problem? Not yet, because we didn't know what are the values of r. Now let's go here, then separate the two values. We have r plus 4 is equal to 0. We have 2r plus 7 is equal to 0. Okay, so transposing plus 4, we have r is equal to 0 minus 4, giving us a final answer of negative 4. Okay, check. In this scenario, we have 2r Transposing plus 7, this will give us 0 minus 7, giving us a result of 2r is equal to negative 7. Not yet isolated, so we divide both sides by 2, we divide both sides by 2, cancel. R is equal to negative 7 over 2. And that is the final answer for our r's. We have r is equal to negative 4 and r is equal to negative 7 over 2. Okay, so that's very easy, right? Okay. But with constant effort of practicing, you will master this kind of method. Now, let's go to the final example. Okay, for our final example, we have 6z squared plus 40 is equal to 31z. Step 1, what we will do is we will arrange our equation into standard form. This is our linear term. So when this will be transposed, it should be in the middle. Okay, so that is 6z squared minus 31z plus 40 is equal to 0. Okay, so you have seen that one becomes a negative 31z. Now, let us apply our first step in solving this kind of scenario. What we will do is we multiply the first term and the last term. So 6 times 40, that will give us 240z squared. Now, since we are talking about negative middle here, we will just consider negative pairs. Okay. So what are the factors of 240? We have negative z and negative 240z, right? We have negative 2z and negative 120z. We have 3z and we have negative 80z. We have 4z and we have negative 60z. We have negative 5z and I think that will give us 48z, negative 48z. Okay. We also have 6z. We have 40z, negative 40z. We also have 8z and we have 30z, negative 30z. Okay. Now we also have 10z and 24z. Okay, negative. We also have 12z and negative 20z. And finally, we have negative 15z and negative 16z. Okay, I think there's nothing more. So what we'll do now is we add everything. Okay, so by adding everything, we have here negative 241z. We have here negative 122z. We have here negative 83z. We have here negative 64z. We have here negative 53z. We have negative 46z. We have negative 38z. We have negative 34z. We have negative 32z. And finally, we have 31z. Okay, so we have our final pair. That is negative 15z and negative 16z. So now we have arrived to our final pair. That is negative 15z and 16z. So let's now just erase this part for us to have our space for the solution. Negative 15z and negative 16z. Okay, now so let's replace our negative 31. So we have 6z squared minus 15z minus 16z plus 40 is equal to 0. Okay, then we have to make our groupings. Okay, but when we make our groupings, especially when the third term is negative, we must put a plus sign on the middle, because if we don't put a plus sign on the middle, because some people might consider that these groupings will become multiplication. Okay, we need to avoid that one. Okay, so now let us extract the common factors, 6z squared and 15z. The common factor is 3z. Okay, so that will have 2z, okay, minus 5. Okay, so 2z minus 5. Now in this part, we have negative 16z plus 40. 16 and 40, what is the greatest common factor? And that is 8. However, we need to extract also the negative sign. So we have negative 8. And we will have positive 2z, and in this part, 40 divided by negative 8 is negative 5. Okay, it's equal to 0. So now, we have our common factors. So let us consider that as 1, 2z minus 5. And we also need to take the two factors outside into one factor. So we have 3z minus 8. Okay, is equal to 0. So those are the factors of our 6z squared minus 31z plus 40. Now, we will solve them separately, equating them to 0. So we have 3z minus 8 is equal to 0. We have here 2z minus 5 is equal to 0. Transposing, we have 3z is equal to 0 plus 8, giving us positive 8 and 3z. Divide both sides by 3. Divide both sides by 3. Cancel. So our final answer is 8 over 3. Okay. So that is our final answer. Now let's go here. We have 2z is equal to 0 plus 5. And we have 2z is equal to 5. Divide both sides by 2. Divide both sides by 2. Cancel. We have our final answer as z is equal to 5 over 2. Okay. So now, for the two values of our z, we have 8 over 3 and 5 over 2. I hope you can now solve quadratic equations with different scenarios using factoring method. However, there is one catch or one disadvantage about this method. Sometimes, there are quadratic equations that cannot be factored. So if that's the case, we need to consider other methods. I hope you have learned many things about our topic for today. And now this is the time that I will test you whether you have mastered our competency for today. And here it is. I hope you have learned a lot of things for our session today. This is still your free access math teacher, Ash. And remember, it is fun to learn mathematics if we are together learning. Thank you and God bless.